The next way that we're going to talk about measuring consistency is using the standard deviation. When calculating the mean absolute deviation, we use the absolute value to make each deviation possible. However, taking the absolute value is not the only way to make sure that the distribution of deviations contains no negatives. Squaring each deviation is another option that will make sure that the deviations don't add to 0. The standard deviation is a measure of variability calculated using deviations from the mean. Understanding what the standard deviation measures. In the context of our model, which is the formula that we have used for everything so far, the formula being performance equals ability plus random chance. Where the standard deviation approximates the typical distance of an athlete's performance will be from his or her ability. For example, consider an NBA player who has the ability to score 20 points per game with a standard deviation of 5 points per game. In 82 games that were simulated for the basketball season for a player with these attributes. This player's, which is noted by here by this graph, has an average performance of about 20. That means 20 is about their middle number. But his individual game performances varied somewhat due to random chance, because every time they score something, it's by random chance. Many of his performances were close to his ability. So, about standard deviation is about 5. So it's going to be somewhere about here and here. And there's a lot of data within this area. That's a lot of data. So most of his ability was about 5 points to the left or right of his average. Many of his performances were close to his ability, but there were several games where his performance was more than 10 points away. So now they're talking about this group of points and this one. Typically, his performances were about 5 from his ability. So about 5 from his ability, and then a couple that was more than 5. So for comparison, here's simulated games for 2 additional players. So this was player 1. This was player 2. And this was player 3. For comparison, here's the games for the 2 additional players. Both distributions have a similar shape and the same center. So that means their mean is still in the middle. This is their mean. But the second player has a standard deviation of 10. So that means most of their data falls within 10 points of the mean, which is true. While the third player only has a standard deviation of 2 points. So that means most of their data is within 2 points of the mean, which if we look is true. For all 3 players, the third player was definitely the most consistent. So the closer your data is to your mean, the more consistent they are. His total points were always between 15 and 25, with typically about 2 points from his ability. However, the first player had points goals between 6 and 34, with the typical performance about 5 points from his ability, while the second player has point totals from 1 to 45, with a typical performance of about 10 points from their ability. These numbers here came from standard deviations, which were given to us. The athlete or team with the smaller standard deviation is considered to be more consistent. So the smaller the standard deviation, the more consistent they are. So how do you find the standard deviation? Well, the first part to this step, to these two steps, are the same for math. You're going to find the mean, which, using the example that we had yesterday, the White Sox runs allowed, our mean was 5.3. After you find the mean, so check, we did step 1. Remember, to find the mean, you add them all up and divide by how many you have. Find the deviations from the mean for each observation in the distribution, which means performance minus the mean. So I'm going to do 4 minus 5.3, which gives me negative 1.3. 2 minus 5.3. It's the same thing, which should give me negative 3.3 minus 5.3, negative 1.3, and so forth until you get to the end of the column. So the next one would be 0.7. So take this time to finish filling out the column. Pause the video now if you need to. Once you find the deviations from the mean, that's step 2, you square each deviation. So you're going to do negative 1.3 times negative 1.3, which gives me 1.69. And then negative 3.3 times negative 3.3, which gives me 10.89. And sorry I didn't leave y'all a lot of room. Just try to squeeze it in as best you can. 1.69. So try the rest. All you're doing is taking this number and you're squaring it. So square all those numbers. So take the time, pause the video if you need to, and start squaring to finish out the bottom row. Once you squared all of the deviations, the next thing that you have to do is add this row. So you're going to add this row together. So find the sum of the deviations squared. When you add them together, you should get 82.1. So here's something a little bit different you probably haven't seen. After you add, you divide by one less than the total number. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One less than 10 is 9. So you're going to do 82.1 divided by 9. And you get 9.12. So I divided. Now, the last step is to square root your result. So you're going to do 9.12 and square root. And you will get 3.02 runs. So this is the standard deviation for the White Sox. Runs allowed. That is the standard deviation. The value of the standard deviation for this one is larger than the mean absolute deviation that we found yesterday. The reason why is because when you are squaring the deviations, this increases the impact of the outliers. So a standard deviation increases the impact of the outliers. So now it's your turn. Find the standard deviation of the White Sox's runs that they scored. Once you finish this part of the problem, bring your paper back to me, and I will tell you what to do from here. If you still have any questions on how to find standard deviation, raise your hand or come see me in the back.